All right, so 15.4 is using matrices to solve systems of equations. So this is just a bunch of the rules and steps. I believe there's a little typo at the top there. It should be C1 for the first equation. I think it says C2. So go ahead and make those necessary adjustments. But basically, if you're given a system of equations, the first coefficient is going to be the coefficient of x, and that's going to be a1. The coefficient of y is going to be b1, and the number that it's equal to is going to be c1. And then the same goes for the second equation, a2, b2, and c2. When this is the case, you can represent this as a matrices, a1, b1, a2, b2, and then you have a matrices x and y, and then you have c1 and c2. And we're going to write it out in this format right here. Once you write it out in this format, it basically states that if you multiply both sides by the inverse of a, you will be able to solve the system of equations. Now, this is the key and most important part about this lesson that you need to know. Notice that when you multiply both sides by the inverse, it comes before the a and the b. That's super, super, super important. You have to multiply inverse times a. Inverse times b. The inverse comes first. So if you want to put a note, inverse always comes first when we're doing this procedure. Feel free to add that in if you feel like you don't know, you're not going to remember or anything like that. Now, what happens when we multiply the inverse times a? We're always going to end up with what? We learned this yesterday. Yeah, 1, 0, 0, 1, which is called the identity. Okay? So we know that side's going to become the identity. The other side's going to become some other 2 by 2 matrix, which represents the answers to x and y. All right, so let's go ahead and try number 1 together. Step 1 is you're going to set it up into the format of a matrices. So it's going to look like this. It's going to be the coefficient of the first x, the coefficient of the first y, the coefficient of the second x, and the coefficient of the second y. Then it's going to be times your variables, first variable, second variable, x, y, has to be x, y, equals whatever the answer is. So that's going to be how you set up your matrices. That's one of the steps I'm going to look for when you're doing this on your test. Now what you need to do is, this is the matrices we call matrix A, and you're going to have to find the inverse of matrix A. So we learned yesterday about how to find the inverse. It's 1 over the, what do we call this? The determinant. Good. So the determinant can be found by doing 2 times 1 minus 4 times negative 3, which is negative 12. Right? And then to get inside here, what do we do with this diagonal here? Swap. Good. And then the other ones, drop their signs or flip their signs. It's going to look like that. Okay? Now I'm basically dividing all of these by 14, right? So this becomes 1 over 14. What's a negative 4 divided by 14 going to reduce to? Negative 2 over 7. Very good. And then over here is going to be 3 over 14, 1 over 7. So this is just 14. So I'm just basically dividing each of those by 14 and reducing when possible for each of those fractions. So anybody have any questions about how I found the inverse? Okay. Now the rule is I essentially am going to have to multiply both sides of this by the inverse, and I know the inverse is always going to come first. So just so you understand what's happening here, I'm going to write it on both sides. So this first matrices, A, is going to be multiplied by the inverse. Then you have x, y. And then, once again, the inverse is going to come first before we write the other matrices. Inverse always comes first. And now at this point, our goal is to multiply these out so we can get this simplified down. So I'm going to start by multiplying these two together. Now, when I multiply these two together, I know the result is going to be 1, 0, 0, 1. But I'm going to make sure I do it because it will tell me if I make a mistake in one of my steps prior to this. If I can confirm that this is the identity, when I get it, I know that I didn't make a mistake. So let's go ahead and do that. So when I multiply these together, I'm going to do this times this is going to be my first section. So that's 1 times 1 times 2 over 14. So that's 2/14 or 1/7, however you want to put it. And that's going to be plus 3 times 4, which is 12/14. Then for this spot down here, it's going to be this times this. So it's going to be -4/7 plus 4/7. So it's just this times this plus this times this. Then we're going to move on to the next row. It's going to be -3/14 plus 3/14. And then lastly, same column, different row, it's going to be 6/7 plus 1/7. So this right here, you're going to notice that it does become, this is 14 over 14, which is 1. This becomes a 0. This becomes a 0. And this becomes 7 over 7, which is 1. And that's, of course, times the x and the y. We haven't dealt with that yet. And then over here, we're also going to have to do this multiplication. Now, this is why it's also so essential that you write it in the correct order. This is a 2 by 2 matrices, and this is a 2 by 1. So for that reason, since the inner numbers match, I'm able to multiply those together, and I know my result will be a what?
2 by 1.
A 2 by 1. But if you had written it in the other order, you actually wouldn't be able to multiply them because the inner numbers would not match. So that's why it's so important that we do it in that correct order. Okay? So let's go ahead and do that multiplication. I'm just going to erase this so I have full room, but, you know, you can keep it. So I'm going to multiply the first row times the first and only column. Yes? Yes, thank you for that. That saves us the headache of making that mistake. Thank you. Sorry about that. Copied it down wrong. So first row times first column, that's going to be -2/14 plus 3 times 24. 72, thank you, over 14. And then my next row times the same column, that's going to be 4/7.
Wait, where'd you get 72?
This times this.
Oh, okay.
Yeah, the numerators. And then for the next one, it's going to be this here times this, which is going to be +4. And then this times this is going to be 24 over 7, right? Everybody see how I got those? And then we're just going to simplify that. So, of course, -2 plus 70 is, 72 is 70. 70 divided by 4, I believe, or 14 is 5. So this whole thing simplifies down to 5. This becomes 28 over 7, which would reduce to what? 4. Now we end up here. Now with this step, you can technically go an additional step if you want to. If you multiply these two matrices out, you're going to end up with a matrices that's just xy equals, but you can actually skip that step because the answer here is just x equals 5 and y equals 4. So just to reiterate this, you all know how to solve this system of equations using either substitution or elimination at this stage. If you get stuck on the test, you could do that to verify your work, but I will make sure to look that you've done the steps because the whole idea is for you to do it using the identity and the inverse and all that. Yes?
Will we get some kind of partial quiz if we get the answer? Or no?
Honestly, no, because this is like an Algebra 1 standard to be able to solve. So I will, if you don't have like the inverse written out, I can't like grant you any credit. Yeah, fair enough. So yeah, you gotta at least have the inverse done for me to show me that you've done it that way. All right.
If you could do this with substitution elimination.
Why are we doing this? Because there's things in math that we would utilize this method for. It's hard because we can't get to everything in this course. But there are reasons that we solve it this way for very, very large systems. It is a little easier. Any other questions? Okay. So I know this method seems kind of like long for a 2 by 2, but it's actually a lot quicker if you're trying to do like solve a system of like a 7 by 7 system with like 7 different variables. So it does have its use, and this is how they program computers actually to solve systems of equations. This is what the computer's doing behind the scenes. All right. So let's go ahead and write this as a matrices system. So that's going to be 6, 5, 2, and 2. This is going to be an x and a y. And then this is going to be 24 and 21. So that's how you're going to set up your system. Now, we know that we have to find our inverse, of course. So to find the inverse, we have to find the determinant. That's going to be 12 minus 10. And then to find what goes on the inside, I know these are going to swap. And then the other ones are going to drop signs, like so. So we end up with this. And then from here, I'm basically just dividing each of these by 2 because 12 minus 10 is 2. So we get 1, negative 5 halves, 3, and negative 1. And this would be our inverse of A. So once we have this, we know we need to multiply both sides of this equation by that. But let's think logically for a second. Now, on the test, I highly recommend that you go ahead and multiply this times this to verify that it's the identity. But we know that it's going to be the identity, right? So when I multiply this times this, we'll write it out so you know where it comes from if you look back to your notes, of course. So we're going to multiply this side by it. And I'm also going to multiply the other side by it as well. And remember, identity has to come first. Okay. So I know what the answer to this problem is. Like I said, if I was taking a test, I would definitely do it out to make sure. But we can just jump to the step that says, oh, I know what this answer is. And we proved it in the last one, right? So I know that this is going to be the identity. So the only really one that I need to for sure do is this one over here, because that's going to be the one that gives me some kind of answer that I need as my answer, right? So when I do this math, I'm going to multiply first row times the first column. That's going to be 24 minus 21. And then my second row, first column, that's going to be negative 120 over 2 plus 3 times 21, which is 63. So this actually simplifies to become 3. And then negative 120 divided by 2 is negative 60. Negative 60 plus 63 is going to be 3. So that's what this is equal to. You can write it out as its full form, like this. So once you get to this point of the problem, now you know what the answer is going to be. It's going to be x equals 3 and y equals 3. Another quick way you could verify your work is to plug both of these numbers back in here. So if I got 3 times 6, that's 18. If I got 2 times 3, that's 6. 18 plus 6 is 24. So you can confirm it by plugging the numbers back into the equation and solving. So I'm going to hand out your homework at this point. There is a little bit of a typo on there, so be just aware of that. I put it on the board.